All right, let's jump right into it. Today we're tackling a question that every single developer has to face. How do you actually decide if a programming language is any good? I mean, there are literally hundreds of languages out there, right? You've got Python, you've got Rust, and everything in between. It is so tempting to just stick with what you know, your personal favorite. But is that always the best call? How do the pros move beyond just personal taste to make a smart, informed decision? Well, the easiest way to think about it is like this. A programming language is just a tool. And in any workshop, the goal isn't to find the one best tool for everything. It's about picking the right tool for the job you have to do right now. A language that's perfect for data science might be a total disaster for web development. So, how do you make that choice? Well, seasoned developers don't just go with their gut feeling. They use a structured approach, a kind of mental framework that helps them break down a language's strengths and weaknesses in a really objective way. And that framework, it really stands on four crucial pillars. You can see them right here: readability, writability, reliability, and finally cost. So let's break down what each of these really means. First up, we have readability, and honestly, this might be the most underrated one of the bunch, but it is incredibly important. Readability is all about how simple it is for a human being, whether that's another programmer on your team or you 6 months from now, to look at the code and just get what's going on. You got to remember, code is usually written once, but it gets read many, many times. So what actually makes a language readable? It really boils down to a few key things. Its overall simplicity, for one. Another is something called orthogonality. Now, that's a fancy word, but all it means is that a small set of features can be combined in predictable ways without causing weird, unexpected side effects. And of course, the design of its syntax and data types plays a huge role. Now, here's where it gets interesting, because simplicity isn't always so simple. Take this example. A language that gives you multiple ways to do the exact same thing, a concept called multiplicity, can actually make the code less readable. If someone reading your code sees 3 different ways to increment a variable, they might start wondering, wait, is there some subtle difference here that I missed? And this right here is a perfect illustration of why data types matter so much. In a language that doesn't have a true or false type, a programmer might just use a number. But what does timeout equals 1 mean? Does it mean the timeout is on, or that it lasts for 1 second? Compare that to timeout equals true. Bam! The intent is perfectly clear. That's good readability. Okay, so let's move on to our second criterion, which is really the other side of that coin, writability. Writability is all about how easily and quickly you can use a language to build something. It's about the whole experience of creating. Does the language feel like it's helping you, or is it constantly getting in your way? Now, some of the key factors here are going to look pretty familiar. Simplicity and orthogonality are just as important for writing code as they are for reading it. But we also have 2 other huge factors: support for abstraction, which lets us build our own tools and hide the messy details, and something called expressivity. Expressivity is a fantastic concept. Basically, it means you can get a lot done with very little code. A language is expressive when it has powerful features that let you say what you want to say concisely and effectively. And this is a perfect example. Remember our increment operator? While having 3 different ways to do it might hurt readability a little, there's no denying that writing count++ is just more expressive and convenient. It's shorter, it's faster to type, and that improves writability. So you see, we're already starting to see a trade-off between our first 2 criteria. Next up, we've got a criterion that is absolutely critical for any serious software project out there: reliability. So what does it mean for a program to be reliable? Simple. It performs the way it's supposed to every single time under all conditions. Now, the language itself can't guarantee your program will be perfect, but it can give you features that make it a whole lot easier to build robust, error-free software. So how does a language help with that? Mostly, it's through 3 things: strong type checking to catch data errors, exception handling to manage problems gracefully when they happen, and features that limit something called aliasing. That's when you have multiple names all pointing to the same piece of memory, and it can lead to some of the most confusing, hard-to-find bugs imaginable. A huge factor for reliability is when that type checking happens. The absolute best case scenario is what's called compile time checking. This means the system catches type errors and other mistakes before the program even runs. It's like having a proofreader who finds all the typos before your book ever goes to print. And that brings us to our 4th and final criterion, which is maybe the most practical one of all: the total cost. Now, when we say cost, we're not just talking about how much you pay for a compiler. The total cost is way bigger. It includes the time and money it takes to train programmers, the cost of actually writing the code, which is directly tied to writability, and the cost of running the program. A slow program that hogs memory can be incredibly expensive in the long run.
And this brings us to the single most important takeaway from all of this. There is no such thing as a perfect language. It does not exist. No language can be the best at all four of these things. Every single language design is a series of choices and compromises. It's all about trade-offs.
This table makes that idea crystal clear. Imagine language A is for rapid prototyping. You want to build something fast. It's going to have high writability and be cheap to develop in, but it sacrifices reliability. Now look at language B. This is for something like flight control software. Here, you need extreme reliability and readability above all else. You're willing to trade a little writability and accept a higher development cost because failure just isn't an option. So why does all this matter to you? Because understanding this framework is what elevates you from just being a coder to being an engineer. It gives you the power to choose the right tool for the job, to justify your decisions, and even to learn new languages faster because you know exactly what to look for. So I'll leave you with this one question. The next time you sit down to work on a project, think about the language you're using. Was it designed mainly for the writer, to prioritize being expressive? Was it designed for the reader, prioritizing clarity? Or was it designed for the owner, prioritizing execution speed and reliability? The answer to that question tells you everything.